Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Gilman reagents, lithium dialkylcuprates, R2CuLi, are well known for performing conjugate 1,4 addition to alpha, beta unsaturated carbonyl compounds rather than direct 1,2 addition to the carbonyl carbon. Moving on to the next step. Identify the substrate. Methyl vinyl ketone, MVK, is CH2 is equal to CHC is equal to O, CH3, and alpha, beta unsaturated ketone, enone. Moving on to the next step. Identify the reagent. Lithium-2 is lithium dimethylcuprate, Gilman reagent. It delivers a methyl nucleophile in a 1,4 conjugate fashion. And for the final step. Mechanism of conjugate addition. The methyl group from lithium-2 adds to the beta carbon, C1 the terminal alkene carbon of MVK. This generates an enolate intermediate at the alpha carbon, adjacent to C is equal to O. Upon aqueous workup, the enolate is protonated to give the saturated ketone. Determine the product. Adding CH3 to the beta carbon of CH2 is equal to CHC is equal to O. CH3 gives CH3, CH2, CH2, is equal to O, CH3, which is pentane 2-1 methylpropyl ketone. This corresponds to option A. Me CH2 CH2C is equal to O, Me. Why other options fail? Option B. This would result from 1,2 addition of 2 methyl groups to the carbonyl and elimination, which is not the pathway for Gilman reagents. Option C. This would require 1,2 addition to the carbonyl carbon giving a tertiary alcohol with 2 added methyls, which is characteristic of organolithiums, RLI, not Gilman reagents. Gilman reagents strongly prefer 1,4 addition. Option D. Cyclopropyl methyl ketone would require an intramolecular cyclization, which does not occur here. Therefore, the correct answer is A. Therefore, the correct answer is option A.